Periodicity Part 2. Here we're going to look at primarily things that deal with size, atomic size, and ion size. We'll note the trends of these are opposite of those that we covered in the first video, Periodicity Part 1. So starting with atomic size, the trends for atomic size are to decrease across a period, and that is because of nuclear charge. As the number of protons gets greater and greater and greater as we go across the periodic table, the pull on the electrons becomes greater and greater, and atoms get smaller and smaller. And the trend in groups is to increase down groups because of shielding. Remember that shielding has to do with the number of energy levels in a particular period. The first period has only one energy level. The second has two energy levels. Third has three. Fourth has four. Fifth has five, and so on. And that tends to block out the nuclear charge. And so if we're to compare, say, sodium and potassium, then potassium would be the larger because it has an additional energy level, which makes it larger, but it also reduces the pull in the outer electrons, making them move further from the nucleus of the atom, making the atom get larger. And if we were to compare sodium and magnesium, then sodium would be larger than magnesium. Sodium has 11 protons, magnesium has 12 protons. The greater nuclear charge makes the electrons get pulled in tighter, making magnesium smaller than the sodium. Trend on the other side would be exactly the opposite. Nitrogen would be smaller than carbon because of a greater nuclear charge, and silicon would be larger than carbon because of shielding. It has an additional energy level. Note that these patterns, decrease across, increase down, are opposite the trends for those things that don't deal with size. So that's the easiest way to remember it. Those things that don't deal with size, increase across, decrease down. Anything that does deal with size, atomic size, ion size, have the opposite trend, decrease across, increase down. The explanation is the same. They increase across or decrease across a period because of nuclear charge. They increase or decrease down a group because of shielding. To understand ion size, you first have to understand electron configuration. Only noble gases are stable, that is, are low energy, and the rest of the elements try to get the electron configuration of a noble gas, meaning they want their outer S and P filled. So here's helium, has only the first energy level, which is filled with 2 electrons. All the rest of the noble gases have their outer S and P filled, such as neon being 2s2, 2p6, argon being 3s2, 3p6, and so on. So we're going to look at the 3 elements right before neon, and then we're going to look at the 3 elements right after neon and see what they must do to become stable. First, the 3 elements before: nitrogen, oxygen, and fluorine. So here's nitrogen's electron configuration with 7 electrons. Note neon has 10 electrons. Its P is filled up. For nitrogen to become stable, it needs to add 3 electrons. Think about what that's going to do to nitrogen. It has 7 protons, being atomic number 7, but now if we add 3 electrons, it's going to have 10 electrons. That means it's got 3 more electrons than protons, so it's going to have a net charge of 3 minus. Oxygen must gain 2 electrons to become like neon, and that is going to give it 8 protons and 10 electrons, and so now it's going to have a 2 minus charge, having gained 2 electrons. And fluorine needs to gain 1 electron to become like neon, and therefore it's going to have 9 protons, 10 electrons, or have a minus 1 charge. Now note, we see a decrease in size even though they all have the same number of electrons. Every one of these has 10 electrons, but nitrogen has only 7 protons, oxygen has 8 protons, fluorine has 9 protons. So again, we see an increase in nuclear charge, and that makes size get smaller as you go from left to right. And so nitrogen is going to be the largest, or I should say the nitride ion is largest. The oxide ion is going to be smaller. Fluoride ion is going to be even smaller. So we see a decrease from left to right. Now let's look at the three metals after neon: sodium, magnesium, and aluminum. And again, neon has 10 electrons, but sodium has 11 electrons. So for sodium to become stable, it must lose one electron, and that is going to give it 11 protons, 10 electrons. Now you've got one more proton than electron, so that's going to give it a positive 1 charge. Magnesium's got 12 electrons, and again, neon only has 10. So magnesium needs to lose 2 electrons. That'll give it 12 protons, 10 electrons, and now it's going to have 2 more protons than electrons, giving it a 2 plus charge. And aluminum's got 13 electrons, so it needs to lose its outer 3p and its 2,3s. In other words, it needs to lose 3 electrons. That's going to give it 13 protons and 10 electrons. So aluminum is going to be a 3 plus charge. Note again, as you go from left to right, we see a decrease in the size of the ions. This time now they are positive ions formed by the loss of electrons, and the loss of electrons is going to lose volume, and becoming positive, it's going to have a greater nuclear charge relative to the number of electrons, which is going to pull the electrons in tighter. So again, we see a decrease in size of the atoms, but the negative ions always get larger because they're gaining electrons. Positive ions always get smaller because they're losing electrons, and electrons make up most of the volume. And if you have more electrons, you have greater repulsion, so you need more room for the electrons, greater volume. And if you lose electrons, you've got fewer electrons, less repulsion, less room needed for those electrons. The end result of this is negative ions are always larger than positive ions, and any one period, the positive or metallic ions decrease in size, the nonmetals decrease in size, but the nonmetals are always larger than the metals. The negative ions are always larger than the positive ions, again because negative ions gain electrons to become stable and the positive ions lose electrons to become stable. So general trends in ion size, again, decrease across because of increased nuclear charge, increase down because of shielding. So if we were to compare potassium and rubidium, then rubidium is going to be larger because of shielding. If we were to compare potassium and calcium, calcium is going to be smaller because of nuclear charge. Potassium will form a 1 plus ion because it only needs to lose 1 electron to become like argon, the noble gas before it. Calcium needs to lose 2 electrons to become like the noble gas before it, become a 2 plus ion. Losing more electrons makes it become smaller, but it's really because of nuclear charge. Hope you learned a lot.